The directional cosines of a vector are the cosines of the angles that the vector makes with the coordinate axes. If I draw my x and y axes with some vector v, there's going to be two angles. Here will be the angle, we call it theta x, the angle with the x-axis, and here is the angle theta y, the angle with the y-axis. The directional cosines will be the cosine of theta x and the cosine of theta y. Remember that the cosine of 0 is 1 and the cosine of pi over 2 radians, or 90 degrees, is 0. So that means that if a vector is in the same direction as an axis, then that directional cosine will be 1. And if the vector is at 90 degrees to an axis, that directional cosine with that axis will be 0. Also, the cosine of pi, so that's at the cosine of 180 degrees, that is equal to -1. So if a vector is pointing in the opposite direction of one of your axes, the corresponding directional cosine will be -1. On that graph above, you can see that v is entirely within the x and y directions. So the z direction there will be pointing directly out of the page. And in that case, the corresponding directional cosine would be 0. So for that graph above, if your z direction is directly out of the screen, that would mean that the cosine of theta z would be equal to 0, because that vector has no component in the z direction out of the screen. Let's say I'm given a vector v. Let's say it's 3, 1, 2 as a column vector. Those are the components in the x, y, and z, or the I, j, and k directions. How do I calculate the directional cosines? Well, remember that cosine is associated with the dot product. So if I have a dot b, that's just the product of the magnitudes times the cosine of the angle between them. So if I take v dot I, that's the unit vector in the x direction, that's going to be equal to the magnitude of v times the magnitude of I, which is just 1, but let's write it in for the moment, times the cosine of the angle between them. And that cosine is actually theta x. It's the angle between the two vectors v and I, which is the angle that v makes with the x-axis, because my unit vector I is in the x direction. So the magnitude of I is just 1, because it's by definition a unit vector. So that's equal to the magnitude of v times the cosine of the angle between them. That's v dot I. And so I can easily solve that to get my directional cosine. The cosine of that angle is equal to v dot I divided by the magnitude of v. So there's the formula for that directional cosine in terms of a dot product between v and the appropriate unit vector. So there's my formula for the x directional cosine and my vector v. So I've written it there two ways, as a row vector and in terms of its components as a sum, 3i plus j plus 2k. Remember that those are the unit vectors in the x, y, and z direction. So what I need is the dot product with I, and I need the magnitude of v. So let's get the magnitude first. The magnitude of v is just the square root of 3 squared plus 1 squared plus 2 squared. It's equal to the square root of 9 plus 1 plus 4. It's equal to the square root of 14. Now what about v dot I? Well, I by definition in terms of its components is this, 1, 0, 0. Similarly, j would be equal to 0, 1, 0, and k would be equal to 0, 0, 1. This is by definition. These are vectors with magnitude 1 in the x, y, and z directions. So v dot I is just going to be equal to 3 times 1 plus 1 times 0 plus 2 times 0 is equal to 3. if I were to write v in terms of general components, let's call them vx, vy, and vz, then v dot I is always just going to be equal to your x component by definition. So in that case, it's 3. So finally, my directional cosine in the x direction, or the cosine of theta x, is equal to, well, v dot I is always just going to be vx, or the component of v in the x direction that's given to us in that row vector there, divided by the magnitude of v. In this case, that's equal to 3 divided by the square root of 14. The directional cosine in the y direction, or the cosine of theta y, will be equal to the y component of v, or vy, divided by the magnitude of v. In this case, vy is 1, so that'll be 1 divided by the square root of 14. And the cosine of theta z, or the directional cosine for the z direction, will be equal to what we'll call vz over v, the magnitude of v. So here that is 2. So those are my 3 directional cosines for that vector 3, 1, 2. One final point about directional cosines. If v is my vector, then v divided by its own magnitude would be a unit vector with the same direction as v. So looking at that, the directional cosine, for example in the x direction, is just equal to the dot product of I with that unit vector in the same direction as v. So that's another way of thinking about the directional cosines. So let's look at an example. This example is based on question 8 in tutorial sheet 7. So a force F of magnitude 136 newtons acts at the point 4, minus 2, 4 in the direction of the line joining 5, 5, 5 to 3, minus 3, 5. Find the moment of the force about the point 9, 9, 3. The first thing I'll do is I'll get a vector in the direction of that force F. So F has the same direction as this vector, the one joining 5, 5, 5 to 3, minus 3, 5. So I'm just going to subtract them from each other. I want 3 minus 3, 5, minus 5, 5, 5. So that's equal to 3 minus 5, minus 3 minus 5, and 5 minus 5. So that's equal to minus 2, minus 8, and 0. So that is the direction of the force F. I'll call that V. Now I want my vector F to have that direction but a magnitude of 136. So F is going to be equal to 136 times V divided by the magnitude of V. The reason for that is that V divided by the magnitude of V will be a vector of magnitude 1 in the direction that we want, and then multiply it by 136 to get a vector with both the magnitude and the direction that we want. So that's equal to 136 times V divided by the magnitude of V. So what's the magnitude of V first of all? It's equal to the square root of minus 2 squared minus 8, well, let's say plus minus 8 squared plus 0 squared. That's equal to 136 times V divided by the square root of 4 plus 64 plus 0. That's equal to 136, I'll put it over here this time, divided by the square root of 68 times V. It so happens that 136 is twice 68, so that's equal to 2 times 68 divided by the square root of 68 times V. So that's just equal to twice the square root of 68 times V, which is then equal to 68 is equal to 17 times 4, so that's 2 times root 4 times root 17 times V is equal to root 4 is 2, so I have 4 times the square root of 17 times v. That's the simplest form for that. So now I can get the components of that vector. So I put my v there into that formula and I get this, so that's equal to minus 2 times 4 times root 17 is minus 8 times the square root of 17. Minus 8 times 4 is minus 32 times the square root of 17, and 0 times anything is just 0. So that finally is my force vector. Now I need my vector r, which is the vector that joins the fulcrum, the point that the force is about, or the moment of the force is about, that we're looking for, the point 993, with the point where the force acts. So the force acts at the point 4, minus 2, 4, and it's about the point 993. So I just subtract those two to get my r vector. That's 4 minus 9, minus 2, minus 9, and 4 minus 3. So that's equal to minus 5, minus 11, and 1. That's my r vector. Now the moment of the force is simply given by r cross f. So the formula for the cross product for r and f, it's going to be r2 f3, so that's the second or y component of r times the third or z component of f, minus r3 f2. The second component will be r3 f1 minus r1 f3, and the third component will be r1 f2 minus r2 f1. So now I'll fill in those numbers. r2 is minus 11, f3 is 0, r3 is 1, and f2 is minus 32 times root 17. My second component, I have r3 is 1, f1 is minus 8 root 17, minus r1, which is minus 5, times f3, which is 0. I'll put my last component on the next line. It's going to be r1, which is minus 5, times f2, which is minus 32 root 17, minus r2, which is minus 11, times f1, which is minus 8 times root 17. So now I'll work all this out. My first component, minus 11 times 0 is 0, and I come out with 32 times root 17. My second component is going to be minus 8 root 17 plus 5. Oh, that's times 0, so it just comes out to be minus 8 times root 17. And my final component then is minus 5 times minus 32 gives 160 times root 17. And I have 3 minuses here, so I get minus 8 times 11 is 88 times root 17. And that finally gives me, this is the same, 160 minus 88 gives me 72 times root 17. And that is the moment of the force. Next, I want the directional cosines of the force. So, what are the directional cosines of that vector? Well, the directional cosine in the x direction is going to be equal to the x component of that vector divided by the magnitude of the vector. So let's get that magnitude first. It's equal to the square root of minus 8 times root 17 to be squared plus minus 32 times the square root of 17 to be squared plus 0 squared. So that's equal to the square root of 64 times 17 plus 32 squared is equal to 1024 times 17 is equal to the square root of 18,496, which as it turns out is just equal to 136. So my directional cosines are, in the x direction, it's equal to the x component divided by 136. In the y direction, it's equal to the y component, or minus 32 times root 17, divided by 136. And in the z direction, cosine of theta z is equal to 0. Finally, what is the moment of a 408 Newton force? Remember that r cross f is equal to the magnitude of r times the magnitude of f times the sine of the angle between them times some unit vector. For a moment of a 408 Newton force, it would be r cross, if I wanted to turn f into a 408 Newton version of itself, I would multiply it by 408 and divide it by its current magnitude, which was 136. So there I've just turned my force from a 136 magnitude 1 to a 408 magnitude 1. So that would just be equal to 408 divided by 136 times r cross f. And I already know r cross f. So all I really have to do is multiply my previous answer by 408 divided by 136, which as it happens is equal to 3. So my answer should be just 3 times my answer for the other moment. So that's just equal to 3 times that, which was my answer from the previous moment. So there you have it, that's that question.